Vivo X90 Pro camera test. Peace be upon you, my dear friends and followers of the channel. How are you today? I hope you are well and in good health. Today with you is a beautiful, new and important video for everyone. This video will be called the Vivo X90 Pro camera test. But before watching the video, subscribe to the channel and like and share so that it reaches the largest number of people. Now let's watch the video and I hope you like it. We put Vivo X90 Pro through rigorous DSLR camera tests to measure its performance in photo and video quality and zoom from an end-user perspective. In this video I will explain the device's performance in a variety of tests and several common use cases and aim to highlight the most important results of our tests through a snippet of the data captured. Overview. Main camera specifications. Primary camera, 50.3 MP 1/00 sensor, 1.6A micro pixels, f/1.8 lens, dual pixel autofocus, optical image stabilizer, ultra wide camera, 12 MP, f/2.0 lens, 108s field of view, autofocus telephoto camera, 50 MP 1/2.4 sensor, 0.7A micro pixel, f/1.6 lens, optical image stabilizer, video, 8K, 4K at 60/30 fps, 1080p at 60/30 fps. Pros: high quality images across the entire zoom range, good exposure and wide dynamic range in photos and video, good detail in outdoor portraits, well controlled noise in videos, effective video stabilization. Cons: autofocus failure, low contrast on faces in backlit scenes, subtle brightness noise in backlit scenes, introducing unnatural texture and artifacts, such as quantization and ghosting. In night mode, dynamic range is more limited in preview than in capture. Autofocus is unstable and choppy sometimes in video. The Vivo X90 Pro makes good use of its 1-inch main camera sensor when it comes to image performance. The camera showed good results in the balance between texture and noise in the image, with a good level of detail as well as a low level of noise even in low light. But when shooting backlit scenes, our test shows that noise removal may not always be effective. Another strength of the Vivo X90 Pro is its exposure performance, as it was able to recover detail in both the shadows and highlights thanks to its wide dynamic range. But the camera struggled in backlit scenes here too, with local tone mapping issues resulting in low contrast on the face. One of the major drawbacks of the photo taking experience was not only the time it took for the main camera to autofocus, but also the occasional failure to focus. The camera provided a rich experience when shooting videos, with good stabilization as well as generally accurate exposure. However, instability of focus and minor problems adjusting to exposure were sometimes noticeable. In many areas, the Vivo X90 Pro's camera performance comes close to the more powerful Vivo X90 Pro Plus version, but there were some noticeable differences that can partly be attributed to the different chipsets in the models. The X90 Pro is equipped with a MediaTek processor, while the X90 Pro Plus has a Snapdragon processor from Qualcomm. For example, although the Vivo X90 Pro kept image noise levels under control well, they were still higher than those of the X90 Pro Plus, and some unwanted image artifacts were noticeable at times. However, the X90 Pro's photo results were particularly impressive in night city landscape photos. In terms of zoom performance, the combination of a primary camera with dedicated ultra-wide and telephoto units in the X90 Pro resulted in good image quality from ultra-wide to mid-range telephoto settings. However, when it came to the long range, the level of detail was rather low. When capturing videos, the X90 Pro produced consistent exposure and color, keeping video noise at very low levels and offering nice texture. This made X90 Pro videos look more natural than X90 Pro Plus videos. About DSLR camera tests. DSLR camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, in which a sophisticated set of metrics allows a group of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, Zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the XMark camera protocol, the Vivo X90 Pro performed very well in our photo tests. Images were well exposed, even in low light. The wide dynamic range also ensured good detail of highlights and shadows, and colors were nice, with a fairly neutral white balance. Outdoor portrait shots showed high levels of detail, and images were well controlled in low light. Autofocus performance was fast, but in some situations, it lacked accuracy. Our testers also noticed some unwanted image artifacts, including shadows and unnatural rendering of textures in nighttime portraits. Exposure and color are the two main characteristics of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors that are evaluated are contrast and dynamic range. For example, the ability to provide visual detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. The Vivo X90 Pro's exposure was accurate in most conditions and outperformed both the Vivo X80 Pro and Samsung Galaxy S22 Ultra, especially in low light. Colors were accurate in most conditions, and white balance was nice, despite some noticeable color shading, as in the sample below. Tone compression was noticeable on both the X90 Pro and X90 Pro Plus, resulting in more unnatural skin tones than on the Huawei Mate 50 Pro. Displaying unnatural skin tone was often noticeable in backlit scenes. Under these types of conditions, the camera had difficulty displaying the tones of the scene in a natural way. F-tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field can be pleasing for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as group photos. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. The X90 Pro's autofocus is a key area that needs improvement. Our testers compare the Vivo phone to the Google Pixel 7 Pro in a natural test scene, where the photographer first focused on a point in the distance and then quickly moved the camera in order to capture a model at a closer distance. In the video, we can see that the capture time after triggering the shutter button was very short for both devices, but on the Vivo phone, the autofocus failed. The same behavior was also evident in laboratory measurements where we frequently encountered out of focus shots. Compared to the Vivo X90 Pro Plus, the X90 Pro seems to use a different autofocus strategy. The X90 Pro tries to capture the subject as quickly as possible, even if focus isn't fully locked yet. The X90 Pro Plus, on the other hand, takes longer to capture, waiting until almost full focus is achieved. As can be seen in the video above, the Pixel 7 Pro delivered excellent results with fast and accurate autofocus. Texture tests analyze the level of detail and texture of objects in images captured in the laboratory as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on chart images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are XMark, DMC, chart and dead leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, and structure in real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also in dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The chart used is the dead leaves chart, and standard measurements such as visual noise derived from ISO 15739. The X90 Pro delivered images with fairly low noise levels. However, compared to the X90 Pro Plus, there was more noise in backlit scenes, resulting in a lower noise score. Effect evaluation addresses lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantization, and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and frequent the effects, the greater the discount points on the score. Below is a list of the main effects observed and corresponding point loss. The X90 Pro's portrait mode performed well in our tests, achieving the same score as the X90 Pro Plus. However, bokeh scenes were rendered differently on the two devices. In this example, there was no visible light improvement on the X90 Pro, while the X90 Pro Plus captured less detail on the face. Depth traces were sometimes visible. Preview tests analyze image quality in the camera app's preview of an image, paying special attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zoomed from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. About Xmark camera zoom tests. Xmark engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low light landscape scenes, using default camera settings and dial zooms at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by running objective measurements of histogram images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. The Vivo X90 Pro captured good image quality across the entire zoom range, from ultra-wide to telephoto. While the top-of-the-line X90 Pro Plus uses two telephoto modules, the Vivo X90 Pro has to make do with just one. In our tests, this resulted in slightly higher noise levels and less precise details. At the ultra-wide end of the telephoto, with a 16mm focal length, the Vivo X90 Pro isn't quite as wide as the flagship model at 14.5mm. However, overall, picture quality was very comparable between the two models, except for the long-range TV settings. The X90 Pro's ultra-wide unit gave a similar result to the X90 Pro Plus. The only difference was in the X90 Pro's narrow field of view, as shown in the example below. Texture rendering was similar between the Vivo X90 Pro and X90 Pro Plus at near and mid-range TV settings. For the X90 Pro, detail preservation increased at 96mm in 100 lux and 1000 lux sliding conditions, which can be explained by the trade-off between texture and noise being no different at this focal length. Therefore, as the noise level rose, the detail level rose as well. Videos captured with the Vivo X90 Pro camera provided stable exposure and consistent color in all conditions. Additionally, video noise was well under control, and the camera was able to achieve good exposure, even in low light. On the downside, our testers noted some focus instability and slight inaccuracy. Videos captured with the Vivo X90 Pro camera had better details than those recorded with the X90 Pro Plus. Texture rendering was also less natural on the X90 Pro Plus, especially in low light. The Vivo X90 Pro also manages noise better than the X90 Pro Plus, especially in low light. Overall, the X90 Pro offered a better texture, noise ratio. Artifacts are evaluated using MTF and ringing measurements on an in vitro SFR chart, as well as frame rate measurements using an LED universal timer. Natural videos are evaluated visually by paying particular attention to artifacts such as aliasing, quantization, occlusion, and color shifting, among others. The more severe and frequent the effects, the more points are deducted from the score. Below is a list of the main effects and their corresponding points loss. At the end of the video, I thank you for watching and I hope you liked it, and see you in a new video.